Hey guys, welcome back. For today's video session, what I'm gonna do is to introduce to a new sensor that is SI1132. Now let's have a look over this sensor in a better way, and for that log on to the website that is controleverything.com and here search for this particular sensor that is SI1132. Now what we got for the sensor, that it's a UV index ambient light sensor, and these are some of its features you can see on my screen. Also, you can purchase the sensor from here. Further, I will be interfacing the ambient light sensor SI1132 with a particle photon, and for that I require a particle code. And I will be going to resource tab, and here comes the particle code sample. Now you can download the particle code sample as zip file from here, like that. Now you can also have the code from GitHub and the repository that is Control Everything community. Now what we require is to make some connections for the hardware required to pursue this video and interface the sensor and the code. Let's have it. Coming to the hardware sections, first of all we require a particle photon, which you are able to see on my screen, and this here is an I2C Shield. It's available on the website controleverything.com, and the idea of putting this I2C Shield in use is to make connections among the other I2C devices, and that connection a lot easier. That's why we are using it. Now gently press the particle photon over the I2C Shield and make a connection. The next part is to have a look over the sensor that is UV index ambient light sensor SI1132, and this here is a connecting cable. Now make the connection of the cable and the sensor, and make sure that the brown wire of the cable should be connected to the ground terminal of the sensor, and same goes for I2C Shield. Now the last part is to power up our particle photon, and for that we require a micro USB cable just like this, and gently insert it over the power jack of the particle photon. So we are done with the connections part of the hardware. Now what we require is to have a closure look over the code. Let's have it. Now coming to the interfacing part, first of all the requirement is to provide the particle code, and for that we have to log in to github.com, and here we have to search for the repository that is Control Everything community, as you can see on my screen. And here we go, and here we have to search for SI1132, and this is the required sensor, and here comes the particle code. Let's have a look over the instructions we need to fulfill first. As you can see, we have to log into a particle photon and set up the device, and the steps are being provided on this very link. Let's open up this link so that we can familiarize ourselves with all the relevant information. As you can see, go through all the steps, please note it down. Now the next part is to download or pull the code. Go to the online ID and copy the code there, and build.particle is the link which will help us to have the code. You can save it from here and name it whatever. Now the next part is to verify and flash the code on the particle photon, and the code output will be displayed in the form of logs at the dashboard, and dashboard.particle user logs will have the results output results on the screen on the monitor like that. Now what we're gonna do is to have a closure look over the particle code. As you can see, it's a .ino extension file. Now first thing you notice in the code that we have included application.h and spark wiring I2C.h header files, and we have defined the address of the sensor that is 0x60. We have some variables initialized here. As you can see, visible IR and UV, status equal to 0. We have void setup, we have set some variables. As you can see, also we have initialized I2C communication as master and initialized serial communication with the baud rate equal to 9600. Now please have a closure look on the explanation I'm providing you regarding the steps. As you can see, enable UV index measurement coefficients, and we are selecting, this is the writing section, we are sending the command to the sensor, selecting coefficient 1 register having address 0x13, default value is 0x29. Then we have to select coefficient 2 register having address 0x14, sending default command for the value that is 0x89. Again, for coefficient 3 register having address 0x15, sending the command to for the default value that is 0x02. And the last coefficient register is coefficient 4 having address 0x16, and command is default value that is 0x00. Now coming to the second part of the writing section, where we are selecting param write register, that is WR register. As you can see, 0x17, enabling UV and visible IR ranges. As you can see, 0xF0 is the command. Selecting the command register having address 0x18, selecting CH list register in RAM having the command address 0x01 or with 0xA0. Then we are selecting the param RD, that is the param read register having address 2E, requesting and reading 1 byte of data. Similarly, we are selecting HWP register having address 0x07, sending the default value, that is 0x17. Then sending the command, selecting first of all the register param WR register having address 0x17, writing or sending the command to small IR photodiode, that is 0x00. Then selecting command register having address 0x18, selecting ALS IR ADC mux register in RAM, that is 0x0E or with 0xA0. Then we are selecting the param read register having address 2E, requesting and reading 1 byte of data. Again, we are selecting param WR register having address 0x17, sending the command to set ADC clock divided by 1 having address 0x00, sending and selecting the command register having address 0x18 and selecting ALS IR ADC gain register in RAM, that is 0x1E or with 0xA0. Then we are selecting param read register having address 2E and we are selecting and requesting reading 1 byte of data from here. Then next part, we are selecting again param write register having address 0x17, setting 511 ADC clock, that is 0x70. Then we are selecting command register having address 0x18, selecting ALS IR ADC counter register in RAM, that is 0x1D or with 0xA0. Then again we are selecting param read register having address 2E, requesting and reading 1 byte of data from this very register. The next part, we are selecting param read register having address 0x17, setting ADC clock divided by 1 having address 0x00. Then selecting the command register addressing 0x18, sending the command to select ALS VIS ADC gain register in RAM having address 0x11 or with 0xA0. Then selecting the param read register having address 2E, that is requesting and reading 1 byte of data from this very register. Again, selecting the param WR register having address 0x17, high signal range, we are sending the command for that, that is 0x20. We are selecting the command register 0x18, selecting ALS IR EDC MISC register in RAM having address 0x1F or with 0xA0. Reading or selecting the param read register having address 2E, requesting and reading 1 byte of data. Then we have to select the param write register having address 0x17, setting 511 ADC clock, selecting command register 0x18, sending the command, that is select ALS VIS ADC counter register in RAM, that is 0x10 or with 0xA0. Now we are selecting param read register having address 0x2E, requesting and reading 1 byte of data again. Now the next part, the last command, writing command, is to select the param WR register having address 0x17, sending the command for high signal range and then selecting the command register having address 0x18, selecting ALS VIS ADC MISC register in RAM, that is 0x12 or with 0xA0. Selecting the param read register having address 2E, requesting and reading 1 byte of data. So these are the commands we are sending to the sensor for getting the response. Now to get the response, we have the void loop function. As you can see, we are selecting the command register having address 0x18. We are starting ALS conversion having address 0x0. Then from the data register we are selecting, that is 0x22. We are requesting 4 bytes of data that consists of visible and IR data. And here comes the conversion part, which is according to the data sheet for SI1132. Then we have to select the data register having address 2C, and we are requesting 2 bytes of data for the ultraviolet UV data. As you can see, the conversion here takes place. At the very end of our code output, we have to display on the screen. We need to show the visible light of source, IR of the source, and UV of the source, and the common unit is lux. That is the luminance unit. Now what we're gonna do is to show the practicality of this code. Let's have it. Now coming to the working environment, the first step is to copy this entire particle code of the sensor, that is SI1132. Copy it and open up the build link we have earlier discussed so that we can create a new file, paste the code there. Paste it and name it SI1132 and save it. And now verify and compile the code, and it's good. Now flash the code. While flashing the code, we have to check for the magenta flash, which will confirm that code is good to go. And let's see. So just now we have our magenta flash, and the flash successful notification is at the bottom, as you can see. Now what we're gonna do is to open up the dashboard user log so that we can have the result output on the screen. As you can see, you have seeing the visible light of source, UV light of the source, and IR of the source. It's almost constant because there is no interference regarding the light source. But when I place some object over the sensor, you can see there is a change regarding visible light and IR and the UV source there, just like that. Now instead, when I place some light source over the sensor, you can see the increase in the values for visible light source, IR, and the UV source, just like that. So this is how the sensor responds along with the particle, photon, and the code. Now what we're gonna do is to show the applications, benefit, and the features for the sensor SI1132. Let's have it. The SI1132 is a low power ultraviolet index and ambient light sensor with I2C digital interface and programmable event interrupt output. This sensor IC includes an analog to digital converter, integrated high sensitivity visible and infrared photodiodes, and digital signal processor. The SI1132 offers excellent performance under a wide dynamic range and a variety of light sources, including direct sunlight. This includes a wide range of applications such as fitness, health, electronics, tablets, smartwatches, smartphone handsets, display backlighting control, and a lot more to mention. This sensor can be purchased from the website, that is controleverything.com, and you can have the code from the resource tab, and after that you can download the code as a zip file. You can also have the code from GitHub repository, that is Control Everything Community, and you can download it from there. Now, in the end, I would just like to make it clear that at any point, if you have any further queries regarding any part of this video tutorial or the sensor, you can contact us on controleverything.com and put your comments on the community page of this website. For blogs and articles which are relevant to this sensor and video, go to our blog instructables.com, and to subscribe more video tutorials like this, you can have a look over our YouTube channel. Now, I hope you enjoyed this video and have a good one yourself. Thanks a lot for watching.